Assalamualaikum and welcome to Mathematics with Shahab Yaqub. Now in this particular video the focus is on S1, it's on permutation in PR, combination in CR and some very basic probability. Now let's look at these questions. Question number 5, let me get my highlighter all ready. It says numbers are formed using some or all of the digits 4, 5, 6 and 7 with no digit being used more than once. Now let me focus on this first line first. Number formation. Number formation is part of permutation because it's about arrangement. Arrangement order makes a difference, therefore it's permutation. Some or all of the digits. That means maybe I can use one digit, I can use two digits, I can use three digits, I can use all four digits. No digit being used more than once, that means repetition of digits is not allowed. So repetition of digit is not allowed. Now let's look at the first part. It says the first part, show that using exactly 3 of the digits, there are 12 different odd numbers that can be formed. So they have already given us the answer as 12. Basically, we have to form a 3-digit number. Now, first of all, let me grab a box and let me draw 2 lines inside the box so there is spaces for 3 digits. Now, which digits are we using? We have 4, 5, 6 and 7. Out of these, 5 and 7 are the odd ones. In order for a number to be odd, the last digit can be odd. It could be 1 of 5 or 7. So let me write 2p1. Remember, np1 is n. That means 2p1 is simply 2. Now, how many digits are left? Out of these 4, if I use any one, therefore 3 digits are left and there is spaces for 2. So let me write any one of the 3, any one of the 2. That is basically 3p2, which comes out to be 6. So along the box we will multiply. That is 3 into 2 into 2p1, and this answer comes out to be exactly 12. And that is how I obtain these 3 marks. That is the first thing. Now let me focus on the second part. It says find how many odd numbers altogether can be formed. Now remember this thing, using some or all of the digits. That means if I start working backwards, I can form a 4-digit odd number. I can form a 3-digit odd number. I can form a 2-digit odd number. I can form a 1-digit odd number. So let me draw boxes. That's the first box, and let me complete the box properly. That is the first one, and then I have divided it into 2 parts. As far as the 3-digit thing is concerned, haven't I just solved it? So let me just copy this thing and let me paste it over here. Let me minimize it, or let me write it like this. That is the 3-digit. And let me just focus a bit over here. Let me focus like this. So 3-digit odd number is already there. 4-digit odd number is what I am focusing on. So let me write it over here. Let me push this thing on the sidelines over here, something like that. Let me make a box and fill it in. So that is the basic thing that is there. And I'm very particular about the sizing. So now this looks good. Now 4-digit odd number, the last digit has to be odd. So the last digit could be 5 or 7, 2p1. Over here the last digit could be 5 or 7. Let me draw a box over here. Let me draw a line over here. It could be any one of 5 or 7, and 1 digit I can simply write it out. Or I can just draw a box like this and then work it out like this. So now let's work it out. Out of 5, 7, 1 digit is used up, 3 digits are left, 3 spaces are there. So any one of 3, any one of 2, any one of 1. Let me multiply. That is 3 into 2 into 1, which is 6 into 2. This comes out to be 12. We already have this 12 over here. Over here 2p1 for any one of these two, and one of the three could occupy this space. Let me write 3p1. So 3 into 2, that comes out to be 6. And the last digit has to be odd for one digit number. It could be any one of these two. So therefore this is 2. Now let me add this all up. That's 12 over here, that's 12 over here, that is 24, 24 plus 6, 30, 30 plus 2, 32. Therefore the total number of ways of forming an odd number using some or all of the digits with no digit being repeated, used more than once, is 32. Let me double check the answer. That is 32, that is 12. All good, all clear. Let's move to question number 6. Now in question number 6, it says a plate of cake holds 12 different cakes. Okay, now let me highlight each one separately. So this first part is about a plate of cakes hold 12 different cakes. Find the number of ways these cakes can be shared between two people, Alex and James, if each receive an odd number of cakes. Now we have solved a question like this from the previous past papers. So let me just solve for this one. So for first part, there is Alex, A for Alex, J for James, and we need odd number. So therefore I can say let's give one cake to Alex, 11 to James, because altogether it's 12. 2 and 10 I cannot write. Why? Because that is not odd, that is even. So let me write like this, 1, 11, and then what can I write? I can write 3, 9, 1, 3, 5, 7, 9, 11, and this is 11, 9, 7, 5, 3, and 1. So that is the working that is required. Now out of 12, if I give 1 to Alex, and that is combination by the way, because we are distributing it. So order does not make a difference. This is NCR. 12C1 and the remaining 11, 11C11. This is 12C3 into 9C9. Are you getting the idea? Out of 12, you're giving 1, 11 are left, the rest of the 11 are there. So even if I don't write this, it doesn't make a difference because NCN is 1. So let me write over here that NCN is 1. And over here 12C5 into 7C7. This is 12C7 into 5C5. This is 12C9 into 3C3. This is 12C11 into 1C1. And let me just evaluate all this thing. So basically I have to add these. So let me just grab a highlighter. And this is 12C1 and 12C3 and 12C5, 12C7, 12C9, 12C11. I just have to add it up. So either this, so 12C1 plus 12C3 plus 12C5, and then it's 12C7 and then 12C9 and then 12C11. So let me grab the calculator and just hold for a second, and let me just evaluate this thing. And this answer is coming out to be what? This is coming out to be 2048. So that is the answer for this particular part. And if you are vigilant enough, you know that 12C1 will have the same value as 12C11. Similarly, 12C3 will have the same value as 12C9. Similarly, 12C5 will have the same value as 12C7. Because remember this thing that NCR is NCN minus R. Use these rules to your benefit so that your working is reduced. That is question number 1. Now let me focus on question number 2. No, not that thick. Question number 2, it says another plate holds 7 cupcakes, each of a different color icing. They are cupcakes, but they are different. And then 4 brownies, each of a different size. So brownies are different sizes and cupcakes are different icings. They all are different. Find the number of different ways these 11 cakes can be arranged in a row if no brownie is next to another brownie, not next to each other. That means this time I have to work on the separated concept. So second part, and there are 7 cupcakes and 4 brownies. So 7 cupcakes. So let me write it: 1, 2, 3, 4, 5, 6, 7. And there are 8 spaces: 1, 2, 3, 4, 5, 6, 7, and 8. In these 8 spaces, let me fit in 4 brownies. And what about these 7 cupcakes? They can arrange themselves in 7 factorial ways. So this is for the cupcakes, this is for the brownies. Use a calculator, and yes, it's a big number, and leave the answer in the exact form. That is 8467, 8467, 200. This is an exact answer. Leave it as it is. So that is the answer for this part. So that is how the space concept is used, the way that I have taught you. The third part. Now it says a plate of biscuits hold 4 identical chocolate biscuits, 6 identical shortbread biscuits, and 2 identical, let me underline 2 identical gingerbread biscuits. So that's 4C, 6S, and 2G. So let me write it out, black marker. That is, let me write it, 4C, 6S, 4C, and then 6S, and then 2 is what? 2 is gingerbread. Okay. Now this is the concept of identical objects. That's part 3. And this was about different. So now what are they asking? They are asking the biscuits are all placed in a row. Find how many different arrangements are possible if the chocolate biscuits are all kept together. So if I am interested in keeping these chocolate biscuits all together, so let me just use this color. So if chocolate biscuits are all kept together, so let me write it: C, 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 and C. What is S? What is left? Not what is S. So this is S, 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 and G, and G. So now this is 1, 2, 3, 4, 5, 6, 7, 8, and 9. That is 9 factorial for this. And what is happening inside the box? Inside the box, that is 4 factorial for the chocolates. But remember that you have 4 C's. These 4 are identical. So divide by 4 factorial for the chocolates. And over here, if I have, let me use another color, this greenish color. I have these 3 and these 3 divided by 6 factorial for the shortbread and divided by 2 factorial for the gingerbread. So now first of all, this comes out to be 1. Nothing is happening inside the box. And now this is 9 factorial, divide by 6 factorial, divide by 2 factorial, and this answer is coming out to be 252. That's an exact answer. Leave the answer in this form. So the first answer is 2048, then this big number, and then 252. So let me highlight it over here. That's 2048, 846, 7200, and 252. Question, that is question number 7. That was the last question of this paper. The first part was quadratics. That's in a different video. And this is statistics. That's it in a different video. Now, first of all, let's start underlining it. Find the number of different ways in which 9 letters of the word toadstool can be arranged so that all 3 O's are together, both T's are together. That is the first part. So let me focus on the first part. So let me write over here, part 1. And let me write the word toadstool, T-O-A-D-S-T-O-O-L. And let me use some colors over here. So there are 2 T's, there are 3 O's, and then there is an A, D, S, and L. So these are the words that we have, the 9 words. So first of all, it's asking the 3 O's are together and both T's are together. So the 3 O's, let me just draw a box. And then there are 2 T's. Let me draw another box, and then there are these different alphabets. So let me write the O's inside, let me write the T's, and then we have A, D, S, and L, and these ones, they are separated 1, 2, 3, 4. So now altogether, if I do the counting 1, 2, 3, 4, 5, and 6, that is 6 factorial. So this answer is 6 factorial. And now what is happening inside the box of O's? What is happening inside the box of T's? So inside the box of O's, that's 3 factorial divided by 3 factorial for the O's, because naturally they are identical, they are alphabets. And for the 2 T's, that is 2 factorial over 2 factorial for the T's. Now this is 1, this is 1. I'm left with what? I'm left with 6 factorial. So the answer of 6 factorial comes out to be 720. That is the answer for this particular part. Second part, let me focus on the second part. It says find the number of different ways in which the 9 letters of the word toadstool can be arranged so that the T's are not together. That means the T's are separated. For 2 alphabets, I can even do the subtraction method. So let me do the subtraction method. So first of all, let me write over here. First of all, without any restriction, for these 9 letters of the word toadstool, that is 9 factorial divided by 2 factorial for the T's, 3 factorial for the O's. Let me grab a calculator, and this comes out to be 30240. And let me also put an equal sign over here. This is without any restriction. What about the T's are together? So the 2 T's are together. So we have these 2 T's inside the box. We have 3 O's on the outside. We have A, D, S, L. So let me just highlight this. So that is the 3 O's are there. And then we have A, D, S, and L are there. So what do we have? We have 1, 2, 3, 4, 5, 6, 7, and 8. That is 8 factorial. What is happening inside the blue box? That is 2 factorial over 2 factorial. And outside, this 8 factorial is divided by 3 factorial for the O's. This is for O's, and this one is for T. So again, simplify your working. This is 1. This is 8 factorial over 3 factorial. And this is coming out to be 6720. This is the 2 T's are together. This is without any restriction. This is together. So without any restriction, this is together. Therefore, what am I interested in? The 2 T's are not together. So for not together, just do the subtraction. So therefore, this is 30240 minus 6720. Work in the exact form. This comes out to be 23520. That is an exact answer. Leave the answer in the exact form. That thing is all done and dusted. So this thing is done. So now let's look at part 3. This time they're asking for a probability. So let me highlight this. Find the probability that a randomly chosen arrangement of the 9 letters of the word toadstool has a T at the beginning and a T at the end. So very simple working, nothing special. Let me just draw a box over here so that things are in their perfect place. And let me just fill some color over here. Okay, so now I'm working on part 3. So we have a T at the beginning and a T at the end. So let me draw a box over here. A T at the beginning, a T at the end. So if a T is at the beginning, it's an identical alphabet. There is one possibility. T at the end, that is also one possibility. 7 factorial is there, divided by 3 factorial for the O's. So let me just write O's and T's over here. So 7 factorial over 3 factorial, how much is that? This answer is coming out to be 840. So this is 840. But since they are asking for probability, 840 divided by what? Divided by this answer, that is right over here, 30240. So divided by this answer, 30240, this is without any restriction. So this has been used twice. So when you do the working, use your calculator definitely. This comes out to be 1 over 36. Leave the answer in the exact form. So let me write 1 over 36 over here because it's kind of overlapping with the red line. So 1 over 36, that's the exact answer. If someone is writing in decimals, that is 0.0278, but this is the rounded off value. And this value is given to 3 significant figure, but any day, any time, I would prefer this value. This is first preference. Why? Because this is exact. Exact is supreme. Fractions are supreme. That's the first thing. Now the last part over here, that is this. 5 letters are selected. Now this is combination. 5 letters are selected from the word toadstool. Find the number of different selections if the 5 letters include at least 2 O's and at least 1 T. So now let me just draw a line like this. And what do we have? We have 2 T's, 3 O's, and then we have A, D, S, and L. So that is what we are working on. So let me first write the 3 O's I've written in green color. So let me just use the same color. So there are 3 O's over here, and then I think I've used 2 T's over here, and then I have A, D, S, L, and let me write the number of ways. And we are select 5 out of 9, but what is the restriction? The restriction are 2. That is at least 2 O, at least 1 T. So this is at least 2 O's and at least 1 T. Okay. Now the first thing is this is part 4. This is combination. Now let me draw a few lines. First of all, I think 3-4 lines would be enough, and let's see how it goes. If there is any additional line needed, I can draw that. So now let me just shift this line a little bit up like this and something like this. I think that would do the job. Now, first of all, over here, let's say I start with 2 O's and I start with 1 T. So 2 O's, 1 T, that is a possibility. Altogether, I need 5. That means the remaining 2 will be selected out of these 4. Let me first write it down. What if I increase the number of O's to 3? So that is 3 O's, and still there is 1 T. That is an option. What about I go to 3 O's and I talk about 2 T's? That is also a possibility. And excuse me, what about this option? That is, there are 2 O's and there are 2 T's. I think I've consumed all the options. Let me go over it again. This is what's available. Okay? This is what's available. So let me just draw a box around it. So this is something like this. And we have to find the number of ways. So now what I've done is that I have started with this at least 2 O's, exactly 2 O, exactly 1 T. I've increased this to 3. I kept it 1. This 3 remains. This became 2. Utilized everything. I kept this fixed. I reduced this. Now let me write over here. 2 are selected. 1 is selected. 0 is selected. 1 is selected. Got the idea? Now, when I select these 2, just discard this. When I select this 1T, just discard this, something like this. So this is not a probability question. It's a number of selection question. And I select out of these 4. So let me write 4C2, which comes out to be 6. I'm selecting 1, 4C1, which comes out to be 4. I'm selecting 0, 4C0, which comes out to be 1. I'm again selecting 1, 4C1, which comes out to be 4. So 6 and 4 is 10, 1 and 4 is 5. Therefore, the total number of ways is coming out to be 15. It's either this or this or this or this. That's how this working is done. Let's double check the answers. The first answer was 720. I think that was the thing. That's right over here. The second answer was this thing, 23520, 23520, perfect. The third answer was 1 over 36, 1 over 36 after the division, 840, 30240, 1 over 36, perfect. And the fourth answer, they have written in their own style. I'm just focusing on the answer, and that is 50. So that's how this particular question is done and dusted. Stay tuned for more content.